Shall we take over? Inter- Actually, we are doing this as two sessions, right? Okay. Uh, in the first session, we have covered. Yes, can you please join? What we covered in the last session? What are the things we covered? Actually, we define what do you mean by statistics, right? Yes. What do you mean by statistics? It's the process of collection of data, classification of data, tabulating, and analyzing at last goes with respect to interpretation. Okay. Actually, it says in some material or in some authors say it's four stages. So collection, classification, tabulation. Tabulation is actually representation, then analysis. Some say it's not just four, it's five because it doesn't stop at analysis. We have to interpret it because only by interpretation we are going to do or we are going to use those data in the research analysis. Okay. So four or five stages it depends on. So we are not going to have this person in the exam, so you need not worry. Four stages or five stages, you need not worry. Okay. Second, we went in detail with respect to different types of classification. You remember? What are the different types of classification? Quantitative. Okay. For because my heading is going through with this, I'll write this in detail. Quantitative, qualitative, chronological, and geographical. And also we discuss what different names we have for this. For example, for chronological, we can say this is time series. Okay, remember? Okay. Uh, Actually, I'll group this quantitative as one single group and all these put together as second group. Okay. Then we went for in details with respect to diagrams. You remember? Okay. So before diagrams, actually we were discussing about representation. Hope you remember. What are the different types of representation? Textual. Yeah. Textual is descriptive form. Writing in paras and paras and paras. Okay. Yes, please. Next is tabulation. Yeah. Diagrams. And we may also have graphs. And we will discuss in detail with respect to tabulation. What do you mean by table? How many parts we have in a table, like table heading, table number, source, footnote, header, etc. And it may be manifold or simple two-fold. Okay. Diagrams. Yes. What are the different diagrams? Yes, you can please refer the pages and you can list me out. Line diagram, or what you call as historiogram. Okay. Am I right with the spelling? Historiogram. Okay. One. Next. Sorry. Ratio chart. Okay. Multiple line chart. Multiple line or multiple axis? Yes. What is? Okay. In bar diagram, we had horizontal bar diagram, vertical bar diagram, multiple bar diagram, component of what you call a subdivided bar diagram. Yeah. Percentage diagram. Okay. And pie diagram. Okay. I think this is what we have discussed so far. Actually, why I'm recalling all these content is what we have discussed so far till here with respect to diagram is all connected with qualitative, chronological, and geographical. And you tried working all these line histogram diagram, historiogram, ratio chart, and multiple chart yesterday. Can you please refer to the tables? Table means for which content you do the bar diagram. You have year, sales, profit. Remember? You have year, material, labor, so on. I just want you to turn those content and refer. Make it faster. See, I'm talking about these content. Year, and the related profit, the corresponding profit for that particular year. What type of classification is this one? Yeah, please. What type of a classification is this one? See, we are very sure we are not talking about quantitative. We are either talking about qualitative, geographical, or chronological. When we say qualitative, we are defining a character, or in general, what we call this as attribute. Chronological is time based. It may be second by second, or date by date, or month by month, or year by year. Okay, or decades by decades. Okay, if you talk about this 5 years budget plan, we'll talk about 5 years and 5 years and 5 years, right? So this is related to time, and geographical is related to, yes, geographical is related to maps. Am I right? Probably you can consider the maps like, one second. Hope you can see the screen now. Yeah. So geographical is related to maps. Like we talk about different states, or we talk about, in case we are talking about GDP for India for the last 10 years, the angle of geographical classification. You agree with me? For the last 10-year data I'm comparing. So I'm talking about, chronological classification. When I say India stands in the fourth or fifth place, now it is in fifth place, fourth place. Okay. So if we talk in this manner, we are talking this in the geographical manner. See, same content can be discussed in various manner. Okay, so it depends on. So today's content is going to be on. So this is all what we did in part one session, first session. And today's content we are going to discuss completely in detail with respect to quantitative methods, which means quantitative classification. If you turn over the pages, can you help me out what we are going to discuss? Yeah, probably you have to turn over from here. Actually, the content is very easy, pa. Yes, it starts over here from the heading, frequency table or something. You'll get like that. From here. I just want you to make a note of all these headings. We are going to discuss all these things. Can you take a note and can refer this table? I request you to write only the headings. Okay. Yes, please join with me. So we're going to start from here, right? Okay. I just want only the headings. Frequency. Yes, please join. What are the things we are going to discuss? It's all very, very important. Maybe in the next topic, we'll be discussing from this base only. Yes, first heading, what do you mean by frequency? Second heading, yes, can you help me out? Frequency, distribution, yeah. Third, variable, okay. That's okay. Next one, this chart, can discuss later. Yeah, class limit, fourth, class boundary, yeah, fifth, adjustment factor for non-overlapping intervals. Overlapping intervals, yes, please. Width or size of the class interval. Actually, we'll not be going in this order, but we are going to cover all these things. Width or size of class interval. So we are using CI for class interval. Okay. The short terms. CL for class limits. CP for class boundaries. Yeah. Seventh one. This one. Frequency density and relative frequency. frequency, density, and relative frequency. Mm, Then we'll go for graphs. Okay, graphical representation, graphs, graphical representation goes with respect to histogram. Okay, before that, I'll add one more heading. We'll be discussing with respect to cumulative frequency. It's there, but I'm listing in this way. Cumulative frequency, then graphs. We'll be discussing four kinds here. First one, histogram. Can you find the heading over there? You'll find another name called as area diagram. Okay, second heading, frequency, polygon. What do you mean by polygon? We have already discussed in the earlier sessions. What do you mean by polygon? Closed bounded figure. Is this a polygon? No. It's closed, not bounded. Bounded means it should be bounded by straight lines. Okay. If I talk about a triangle, if I talk about a pentagon, yes, it's all bounded because it's closed and bounded. So two conditions for polygon. If you want to make any notings for polygon, you can please make a note. What do you mean by polygon? It should be closed and it should be bounded by straight lines. This is what you call as polygon. Okay. Circle is not a polygon. Obviously, triangle, closed then, bounded by straight lines. Pentagon is a polygon. Okay. Yes. Third graph or related to graphs. Yes. Frequency, curve. Okay. Then you'll find curves. Hope it is fine. We're going to discuss all these contents for today's session. Done? Okay. Actually, when we talk about frequency, you can have it in brackets. We'll be discussing on tally marks and we'll be discussing on tally bars. That is blocks. Tally marks or tally bars and tally blocks. So whenever I go for, I'm going to take an example bar. Whenever I go for taking the example and discussing, you have to make a tick mark simultaneously. Is it okay? Make yourself confident that only these 10 things are available under this content for quantitative classification. Okay, depending on this content only, we'll go further for next topic, mean, median, and mean. See, this is completely dealing with quantitative classification only. We are not going to cover qualitative here because qualitative, geographical, and chronological cannot be used for further analysis. See, when we talk about statistics, collection, classification, tabulation is quite simple. But when we discuss for analysis, it's not much simple. Analysis also somewhat simple. If I ask you to find the mean value, yes, you can find it. If I ask you to find median value, yes, you'll find it. Mode, you'll find exam interview. Find the mean value, find the median value. Nobody is going to give that one. They'll be asking you to interpret the result. Interpretation is only that the professionals can do. So interpretation is with the help of the skills you are going to apply. So with the help of mean value, what you're going to do. With the help of median value, what you're going to do. Okay. But obviously, that's not covered in our syllabus for foundation level. Happy or not happy? Knowledge level is required, but for foundation level is actually we are not using it for that interpretation level, but not even in inter level, probably in final level you'll be using it. Final level you'll find like in the exam hall itself, we have to assume some data. Seeing the exam questions, you have to assume some data, you have to make some assumptions, and that should be a valid assumption. So it's all depending on interpretation only you can do it. So interpretation is not associated with the accounts or with statistics. It's all application. Is it okay? So we'll discuss all these 10 headings in detail. Shall we take over? Yeah. I'll give you a small activity like the activity is we should be very genuine, okay? I'll give you 5 questions, not 5, 10 questions in set theory and permutation. The topics we covered earlier, okay? It's a sudden test. Usually we did this in school. There'll be a sudden test, surprise test. Okay. How many like sudden and surprise test? Definitely, I don't like it. It's very horrible. Okay. Even for the final exam, we have the timetable 1 month before. Why they give the sudden and surprise test and all? Okay. So let me come over here. So I give you 10 questions. Okay. In set theory and permutation and combination. What would be your score? What would be your score? Okay. A genuine one. Ma'am, I did not at all know have any knowledge about set theory, ma'am, permutation and combination, ma'am. I will get only zero, ma'am. No issues. Be genuine. Because somewhere or the other, I want a zero number here. Okay. Will you do it for me? Yes, please. Yeah, first one. I don't know the student's name and all, and I don't want to take much time on this. So, for convenience sake, I'll write the student's name 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, as of now. Yeah, let me start from here. What was your score? Out of 10? So, this is out of 10. 7, 6. Okay, 7, 8, 6, 0, 9, 6, 5, here, 9, 6, 2, okay, and Vasant 7, Ranjit 3, Roshan is 5, Niranjana is 7, Srimati is 6. Is anybody else missed out? Okay, I have how many students here in total? 17 students I have, okay. So number 7 and 3, though. What was the number? 6. So how many total number of students I have? Total number of students? 17 students, okay. What was the first heading we are going to discuss is frequency. Okay, see, I'm not going to go in this order. I'm just referring this one. First is we are going to discuss on frequency. Before that, by definition, actually what I have to do, by definition of statistics, what I have to do, I have to go for, yeah, please, please. What's the definition of statistics? Collection of data. Make yourself sure I have collected the data. I gave you 10 questions and you wrote the exam and you got corrected and you got 0 also. Okay, because it's a primary data. Okay, so collection of data is done. Clear? Next, I have to go for classification. Yes, tell me what type of a classification is this one? Obviously, we're going to discuss with quantitative, as I said. It's a quantitative classification. Why? Shall I state as classification with respect to qualitative or chronological? I don't think so. Chronological will be okay with this. Okay, because I did not collect that much sufficient data. Probably, if I have collected the data like what I say, Tamil Nadu students and out of Tamil Nadu students. Okay, probably this first student is Tamil Nadu. Second student is other state, Kerala. Another one student Karnataka. Another one student Andhra. So I may be classifying in a different way. So I'm not going to do that because my intention is to go with the classification with respect to quantitative only. Okay. And if I talk about my students who have secured less than 5 is okay students. 5 to 8 is average students. Above 8 is better or good. That is the classification called as quantitative classification. But again, my intention is to do the quantitative. Okay. Yes. Tell what type of classification I can do here. That is, how can I split here? Probably my score is, the maximum score can be 10 only. Shall I make this type of a classification? Just refer. Probably like uh, 0 to 2. or 0 and 1 and 2 to 4. See, there is no particular order and all. I'm writing in any order. 5 to 7, 7 to 10. If I want to give in a beautiful manner, probably I might have stated like this: 0 to 2, 2 to 4, 4 to 6, 6 to 8, and 8 to 10. But as of now, I'm not following this one. I want to make myself comfortable. So 0 to 1, 2 to 4, 5 to 7, and 7 to 10. Okay. So this type of a classification I'm defining. First one. Second, uh, as I was saying, this is only with respect to quantitative classification. Now I go for framing the frequency distribution table. What I'm doing here? Frequency distribution table. For a frequency distribution table, this is with respect to the marks. So I give the heading as marks. And for this range of marks, 0 to 1, 2 to 4, 5 to 7, and 7 to 10. For this range of marks, what I'm going to do here is, I'm going to give the number of students secured in this range. Number of students. In between the two columns, I'll have the heading for tally marks or tally bars or tally blocks. Usually we'll get the heading as tally bars only. But tally blocks is nothing but containing in 5 and 5s. So this is mark 0 to 1. Directly I cannot go and search who has got 0 and who has got 1. So what I'm going to do here is, I'm going to start from the beginning. 7. Okay. I'll put a bar over here or here. There's a confusion. Okay. If you say 5 to 7 is okay, okay. 7 to 10 is okay, okay. If you feel like saying 7 to 10 is okay. I may be preferring 5 to 7 is okay. Okay. Anything. So what you prefer? As you said, 7 to 10. Okay. So this is how it's taught in the school. No, I'm asking you. Okay, 7 to 10. I'll put a bar. Second one. Yeah, please join. So over here. Yeah. Third. Yeah. Next. Over here. Yeah. Over here. Okay. She is solo, no? Next. Ah. 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 Block. Okay. Yeah. Over here. Sorry. Ah. Ah. Over here. Ah. Mm. Mm. 7. Okay. So how many bars over here? 1. How many bars over here? 2. I think 7 and 7. We're getting 17 totally. 14. 3 and yeah, 70. This is what you call as total number of students. It will match. This was asked once in the exam. What do you mean by total number of students? Is nothing but what you call this as total frequency. Okay. You call this as total frequency. If we talk about this value 2, this is representing which class? This is what you call as class, the range 2 to 4. This is what you call as class frequency. Now you come back to the previous page. You have written frequency. You have noted what is tally marks or tally bars and tally blocks. Along with that, you are remembering something, two different frequencies called as class frequency and total frequency. Can you please make a note of this one? These are the different terms you have to remember. Okay. Shall I take over? Online continuing. Actually, this table doesn't looks nice. So what I'm going to do here is, I'm going to take a number which is common to both. Which number I can take, which means common to both. Instead of 1 and 2, I'm going to take a mid value. You have taken a bus or auto, leave of bus. You have taken an auto. That auto wala, he will say, 100 rupees, madam, to go to that place. If you go with your grandmothers, okay, they'll say, I'll give only 50 rupees. I've heard of this experience. We have got this experience. That's why I won't go with my grandma till. அநியாயமா கேக்குறீங்க அப்படின்னு சொல்லி திட்டுவாங்க. 150 rupees. This auto wala will come for 90 rupees. My grandma, she'll come for 60 rupees. Then this auto wala will come for 80. And my grandma will come for 70. This auto wala will say, even 1 rupee, if you're reducing, I'll not drive. This will say, if you're not come for 70 rupees, then no issues, I'll take another auto. Then this auto wala will get tensed up. So at last, this argument will end up with how much? 75. Okay. This is what you call as mid-value. Actually, we call this as mean. You agree? That is 100 plus 50 divided by 2, which is 75. Okay. We can call this as mean in one area. You can call this as mid-value. Okay. Whatever it is. Okay. Now tell me, what is our area here? 1 and 2. We want to share the value. So, how can I share the value? 1 plus 2 divided by 3, which is 1.5. Divided by 2. Okay. Divided by 2, which is 1.5. Either I can do in this method, or what is this value? 2. What is this value? 1. 2 minus 1. What is the value? 2 minus 1. 1. Divide by 2, which is 0.5. To this, I'll add 0.5. To this, I'll subtract 0.5. So, I'll get 1.5 and 1.5. So, my first class interval will be 0 to 1. 0 to 1.5. Second one will be 1.5 to, again the problem arises. Here 4, here 5. So, what value I can share? The difference is 1. I share it and give. So, what's the value you get? This is 4.5 and this is 4.5. And what about this one? Not necessary of sharing, is already shared here. So, I can keep this as 7 itself. And this is 7 to 10. Okay. This is what you call as class limits and class boundaries. See, I take 0 and 1, 2 and 4. The actual values I take, because I'm taking this from the classification what I'm discussing. If I take the actual values and you find there is a difference of value, like 1 and 2 is there is no continuity. In this case, you call this as class limits. But if I make a sharing of the values, which means it becomes boundary here. This is what you call as class boundaries. So we have learned 2 more terms, class limits and class boundaries. We can make a tick mark. So first one we have done. Frequency. Class limits over. Class boundary over. Class distribution, frequency distribution not at over. Okay. Probably you may be analyzing. I might be sleeping in the class. That's why I don't know what is frequency distribution. I did not have to discuss. Okay. Okay, fine. Next. This is what you call as class boundaries. What do you mean by class interval then? See, class boundaries, I'm talking about the final value. Class limits, I'm talking about the final value. To go more in detail, if I take class limits, we have 2 types of class limits. One is lower class limits and another one is upper class limits. Likewise, if I talk about class boundaries, I'll be having lower class boundary and I'll be having upper class boundary. Okay. But what I mean by class interval is the full set of values. So probably I'm talking about the 7 to 10. This is what you call as class interval. What's the range of this value? 7 to 10? 3 units, right? 10 minus 7. 10 minus 7. This is what you call as range. So what are the terms we have learned? Lower class limit, upper class limit. Lower class boundary, upper class boundary. Then class interval. The difference of the 2 values is what you call as the range. Usually when we go for calculating the range, we have to consider class boundaries only. Please make a note of it. When we talk about class boundaries, usually we go with okay, probably you can make somewhere over here. You can take note of 2 types of classification: lower class limit and upper class limit. Okay, class boundaries. lower class boundary and upper class boundary. Okay. And you can include class interval is the full range of value, and the range when you calculate you have to take the reference with respect to class boundaries. So upper class boundary minus lower class boundary. Can you define this as a formula? See, actually we don't have any particular formula and all, but in the exam they ask what is the range. It's upper class boundary minus lower class boundary. And if we talk about the range for each and every class interval, there may be a different range. You agree? You agree? What I'm trying to say here is, if I talk about this one, uh, 0 to 1.5, 1.5 to 4.5. I'm taking the class boundaries, okay? 4.5 to 7, 7 to 10. Yes. For this class interval, what is the range? For this particular 1.5. Have you got it? Upper class boundary minus lower class boundary. Yeah, here. 3. Here. So you can understand, right? Okay. Here. What is the overall range? The maximum value minus the smallest value. This is what you call as the overall range. And this value is what you call as the class range. What do you call this one as? Class range. Okay. So you can refer here, this is class range. Yes, you can please make a note of it. Class ranges for that particular class interval you are finding. Okay. Overall range means completely. Still frequency distribution is not over. The second one is still pending. Okay. Shall I take over? What do you mean by distribution? Distributing. Okay, it's a normal term. What do you mean by frequency? We'll take our own example, the total number of students. What was my total number of students in the session? 17. Okay. This 17 I'm distributing. That's what is called as frequency distribution table. What was the heading? Marks and leave of tally bars now. I don't want hereafter. Marks and number of students. Actually, this is a very general heading. Usually when we go for calculating marks, we take marks and number of students. But actually the generic name for this is called as class interval, and this is called as frequency. Okay. Yes, what is the class interval? Usually we go for boundaries only. Yeah, tell me. 0 to, I think 1.5, 1.5 to 4.5, 4.5 to 7, 7 to 10. And number of students? 1, 2, 7, 7. Yeah, totally 17. See, this 17 is 1 plus 2 plus 7 plus 7. That's why it's called as frequency distribution. That's why it's called as frequency distribution. Okay. We are going to refer two more terms. One is frequency density and another one is relative frequency. Okay. See, each and every time you cannot find frequency density. When you can find frequency density means only when there is unequal class interval. There is unequal range for class interval. What is the class interval for this one? There is range. It's 1.5. It's 3. It's 2.5. And it's totally different, right? It's not uniform. It's not uniform. It's totally different. In this case, we cannot consider the value 1 as same and 2 as same. What we do here is we'll go for neutralizing it and we go for finding frequency density. So you need to add a column for frequency density. What is frequency density means? You take the class frequency divided by width of the class interval. What do you mean by width? Width or size? What do you mean by width? The range, the class range. So I can please make a note here. The class range has another name called as width or size of class interval. Please make a note of it. This class range has the name width or size of the class interval. It need not be same for all. It may be differing in case to case basis. Okay, shall we take over? Call this as width or size of class interval. Continuing. Yes, tell me, Pa. First case. Yeah, first case. Yeah, please. 1 divided by 70. Okay. Yes, 2 divided by 7 divided by 7 divided by 70. That's it. You need not have in fractions. It depends on decimals, fractions, anything you can have. Okay. Next, shall I continue? Next term is relative frequency. What's the next term? Relative frequency. Whenever you use the term relative, you have to compare the values with the total value. Okay. Relative frequency. The formula is the class frequency divided by total frequency. What's the class frequency here? First one. You need not worry about this. What is the original class frequency? 1 divided by 70. Usually we represent in percentage. Okay. Oh, sorry. I have to take without the class interval, right? I'm very sorry. Forgot. Actually, I wrote the formula right. Here I should not take 17, right? What I have to take? See, I totally mistook. Sorry. 1 divided by 1.5. Yeah. 1 divided by 1.5 because the formula here is divided by width. Okay. So it's 1 divided by 1.5 and here it is was a class frequency 2. So 2 divided by 1.5. Next is 7. 7 divided by 2.5. 7 divided by 2.5 and okay 2 divided by 3. Okay. Then 7 divided by 2.5 and 7 divided by 3. Okay, it's clear now. Then relative frequency is class frequency divided by total frequency. Yeah, tell me. What is class frequency? 1. What is the total frequency? 70. 1 divided by 70. Then 2 is the class frequency divided by total frequency 70. So 7 divided by 70 and 7 divided by 70. Okay. If you represent in this manner, this is what you call as relative frequency. Usually relative frequency will give in percentage. Please make a note. Relative frequency will be dealt in percentage. If you wanted to make a note of this table, yes, you can make a note. So now we have done with what do you mean by frequency distribution and frequency distribution table. Okay. Frequency distribution table will not have this tally marks column. Directly will write marks and number of students. Okay. Let us come for making the class limits to class boundaries. Class limits are there. We have converted to class boundaries. Remember what we did? 0 to, I think we had 1, then 2 to 4. This one I want to make it sharing. So I took 2. I did 2 ways. First way is 1 plus 2 divided by 2, which is 3 by 2, which is 1.5. So I made this as 1.5. Okay. Else I can take this way where 2 minus 1 divided by 2, which is 0.5. To this I'll add 0.5. To this I subtract 0.5. Now we are going to make this as a formula. Can you help me out? What terms I can use it? First, let me go for the first method. What is this one? Here actually we are dealing with two set of class intervals. Okay. Yes. What is this one? This is the upper class limit. Shall I write it here? Upper class limit of class interval. Okay. Plus what is this 2? Lower class limit of the succeeding class interval. Okay. Divided by, divided by always 2 only. So directly what I'll get it here? I'll get the class boundaries. Okay. Class boundary is equal to this one. Or I can write this way also. See, I'm considering with respect to this class interval. So shall I write this 2 as lower class limit of class interval? And what is this 1 then? Upper class limit of preceding class interval. See, what is preceding means? the one before. What is succeeding means the one after. So this is succeeding class interval. This is preceding class interval. Precedes. Okay. Divide by, use any one here. What about this one? Yeah, please join. 2. The same way. Upper class limit or lower class limit of the succeeding or preceding. Can you try this formula? Yes, please try. It will look somewhat similar to this. Yes, please try. Yes, please. What's 2? Probably I'll go with this one, right? 2 is lower class limit of succeeding class interval minus what is 1? Upper class limit of preceding class interval, right? Preceding class interval divided by 2 only. But if you do this, you'll get only 0.5. What I have to do with the 0.5? I have to add here and I have to subtract here. When I go for this 1 to 1.5, actually I have to find this and add with respect to upper class limit. Am I right? I'm finding the 0.5. What I have to do for getting 1 to 1.5? I had to add 0.5. What is this 1? Upper class limit. For the second, 2 to 1.5. So with this formula, I have to subtract this lower class limit. Okay. Yes, the second one. This 2 is what? Upper class limit of preceding preceding class interval. So I need not have preceding here. Minus lower class limit of, this is succeeding. Yeah, succeeding class interval minus lower class limit of class interval divided by 2. You'll get 0.5. Okay. Shall I go for the next heading? Next heading is, you have to find the mid value. Shall we go for finding the mid value? Mid value, or we use the term called as midpoint of a class interval. Mid value of midpoint of a class interval. For convenience sake, for each and every class interval you can find it. For convenience sake, I'll take the class interval, the last one, 7 to 10. Okay, what's the mid value? You have to find the mid value. Either you can do subtract 10 minus 7 divided by 2, which is 3 by 2, which is 1.5. This 1.5 could be added over here or subtracted over here. Okay, what is this 10? Yeah, give me as a formula now. What is this 10? Upper class limit, upper class boundary, not limit, boundary. Actually, here also you can use limit or boundary, but instead we are converting this to boundary, we'll use limits here. Okay, here we are going to use boundary only. We should not have limits. Okay, yes, upper class boundary minus lower class boundary divided by 2. You will get this 1.5. For this, you have to add 1.5. For this, you have to subtract 1.5. So your formula will be here. For your formula will be here. Lower class boundary plus this formula. Okay, I'll put a box. Okay. For getting the 10 value, it's upper class boundary minus this box. Okay. Clear? That's it. This is what you call as the adjustment factor. Because you're adjusting, right? What do you call as adjustment? Is it okay? Shall I take over? See what are the things we have covered? Frequency density, class limits, class boundary, converting class limits to class boundary. What do you mean by width or size of the class interval? Adjustment factor for the non-overlapping is what you call as the midpoint or whatever it is. Okay, you have like two formulas. Then width or size of the class interval. Frequency density is over. Relative frequency is over. Before going for cumulative frequency and graph, I just want to rewrite this problem for convenience sake. Okay. So this was my problem, right? This was my problem. Instead of taking with unequal widths, I want to directly go for equal widths. So let me have marks, the classification with the class interval 0 to 4, 0 to 2, 2 to 4, 4 to 6, 6 to 8, and 8 to 10. I'll tell you why I'm not working with the old one. Okay. The reason is simple, but let me finish off this one, then I'll tell you why. Okay. Then marks, number of students. Yes, can you tell me number of students? Actually, we need to have tally bars, right? Tally bars. Yes, but please join. First is, I'll put an into mark. First is 7. So over here. Next is 6. Over here or here. First or second. Shall I take 4 to 6 this time? Okay. There's no hard and fast rule. So let me go for 4 to 6. Yeah. Next is 7. Next is 8. I'll take this one. Because if I take the first one, I have to take the first one for the same. See, for 6, I'm taking this class interval, right? For 8, I have to take this class interval. Okay, this is how I'm evenly sharing. Then 6. Yeah, please join. 0. Then 9. Then 6. 5, 5, 5. Yeah. 9. Yeah. 6. 2. 7. Oh, sorry. 2. Okay. 7. Am I right? Yeah. 14. 3. Over here. For 15th student, it's 5. Over here. Yeah. 7. Over here. 6. Over here. Yeah. Frequency, number of students. It's 2. 7. I'm getting 17. Yeah, 17. Tell me, the earlier one was better or this one was better? Which is better? This somewhat looks beautiful, like 0 to 2. The classification is better. Okay. The same thing you can find relative frequency. You will not find frequency density. Why? Because all the class intervals are equal. The width of the class interval is equal. You need not find. Actually, frequency density is meant for unequal class intervals only. So we are not going to find frequency density. As frequency density concept is not at all applicable over here. So we will be finding relative density as usual, everything. Then we have to go particularly for cumulative frequency and graphs. Shall I take over? For convenience sake, what I'm going to do here is I'll take a line or a horizontal line and I make the markings. What's the first value? 0 to 2, then 2 to 4, then 4 to 6, 8 and 10. Number of students in 0 to 2 range, it's 2, 1, 7, 5 and 2. If that happens a situation, how many students have got less than 6 marks? Because usually we'll have this question, right? How many got above 8? How many got below 6? Okay. If you talk about all lesser than values, we call this as less than cumulative frequency. What do you mean by cumulative? Cumulative means addition. Accumulation is what you call as cumulative. If we talk all about greater than values, we call this as greater than cumulative frequency. Okay. Yes. Less than 0. Yeah. Less than 0. Yeah. Get me the value. How many are less than 0? Nobody are less than 0. Okay. Less than 2. You may ask me why you are not taking less than 1, ma'am. Will not take because we are talking about only class boundaries. So less than 0, less than 2, less than 4, less than 6, less than 8, less than 10. Only these things we take. Yeah. Less than 0, less than 2, how many? 2. Okay. Less than 4, 2 plus 1. This is what I call as cumulative, accumulation of values. We accumulate step by step. Less than 2, it's 2. Sorry, less than 4 I'm talking about. It's 2. Along with this, we add 1, which is 3. Yes, 6. It's 10. Why? Because along with this, you add 7, which is 3 now. Now we add 7, which is 10. Less than 8, you add this 5, which is 10 plus 5, 15. Less than 10, you add step by step addition. So 15 plus 2, which is 70. You have to make a note here. First value less than 0 will be always 0 because my class values starts from 0 only. So you cannot find any value less than 0. So it's always 0. And less than 10. All of my students have got less than or equal. See, less than means less than or equal to also. So less than or equal to 10. So you will get the final value here. What's the final value? It's the total value. You'll call this is total frequency, which is summation f. F is the frequency term. F is used for frequency. So you call this as summation. This summation f will be the total value. This I discuss for less than CF term. Shall we discuss for greater than CF? The same thing. You can please join now. Yeah. Greater than 0, greater than 2, greater than 4, greater than 6, greater than 8, greater than 10. Yeah, please join. Greater than 0. Everybody are greater than 0. Greater than means greater than or equal to. Okay, so what's the value? 70. And you have to make a note, the 17 will be nothing but summation f. Yes, greater than 2. Step by step you have to do the greater than 2 means you should not consider this 2. Okay, so which means 70 minus 2. Here you will go for step by step addition. Here you go for step by step reducing, subtraction. So this is 15, greater than 4. From this 15, you have to remove this 1. Yeah, 14. From this 14, greater than 6. You cannot take 7 now. So minus 7 is greater than 8. Minus 5. So which is 2. Yes, minus 2, 0. Definitely this value will end up with 0 only. Because the logic is same. What's the logic? How many have secured greater than 10? Nobody. Because the maximum marks I have provided is 10 only. Okay. And this is how many have got greater than 0? Everybody. So this is with respect to less than CF and this is with respect to greater than CF. Now what we are going to do here is we are going to give the heading for this. For this one. What heading will give? Actually, this is marks only we are going to give. I want to give for the generic heading. Because my problems with marks and number of students, it's going to be marks and number of students. But what heading you are going to give here is less than CF limits. And this is greater than CF limits. Okay. But usually we'll not use these terms at all. We'll use marks, number of students. And you call this as less than cumulative frequency. You call this as greater than cumulative frequency. If you refer these values, what I'm encircling here, what is this value? 0, 2, 4, 6 and all. Class boundaries. Class boundary for which one? 0, 0 to 2, it starts with 0. So class boundary for 0. What class boundary is this one? Upper class boundary or lower class boundary? So this one happens to be lower class boundaries and all here happens to be, it's because we are not going to consider this one. Upper class boundaries. Okay. Sorry, not this one. This is upper class boundary because we are not going to consider 0 at all. And this is lower class boundary. Is it okay? So you can please make a note of it. With this, we are going to go for further graphs. We go for graphs. When we talk about graphs, make sure we'll have two axes. Probably even for the diagrammatic representation, we might have drawn like x-axis and y-axis, but will not have a mention on scale. Will not mention the scale. You know what you mean by scale? X-axis 1 centimeter equal. Will not mention the scale. But here usually will mention. Okay, just tell me what's the scale I shall take here. I am taking this column and this column, the original table. Okay, not with cumulative frequency. Yeah, tell me. It's 217. So I can take in. Uh, I can take up to 8, right? So I can take 1, 2, 3, 4, 5, 6, 7, and 8. Is it okay for y-axis? For x-axis, 0 to 2. Shall I take 0 to 2, 2 to 4? Okay, so 0, 2, 4, 6, 8, 10. Okay. Yeah, first one. For 0 to 2, it is 2. It's nothing. I have to draw the bars. This is what you call as histogram. Okay. So 0 to 2 is 2. I'll draw bar. Okay. Second, 2 to 4 is 1. Yeah. 4 to 6. So I'll get till here. Am I right? Okay. Then 6 to 8, it's 5. 8 to 10, it's 2. Okay. This is what you call as histogram. Histogram. Histogram is over. Next is frequency polygon. I take the mid value. How you find the mid value? You know, 0 to 2. 2 minus 0 is 2 divided by 2. Okay, so what's the value here? Mid value. Yes, could you please join? Usually we'll represent this by small m. Mid value is represented with the alphabet small m. Yeah, tell me what's the mid value here? For 0 to 2 is 1. 2 to 4 is 3. Then it's 5, 7 and 9. So for this one, for this 2, I take it as x and y coordinates. See, we write like this, right? 1 comma 2. Okay, and this is 3 comma 1, and this is 5 comma 7, 7 comma 5, and 9 comma 2. Yeah, so first one is 1 comma 2. This is the point. Okay, then 2 comma 4, it's this point. Here it will be this point, and this point, and this point. Actually, instead of doing this way, from the histogram, if I mark the mid values, it will be very easy. Here my problem is very simple, 0 to 2, 2 to 4 and so on. So that's why mid-value finding is kind of somewhat easy. But from the histogram, I can directly make it easier by joining the mid-values and drawing by a freehand curve. What do you mean by freehand curve is you not use scale. Okay. And we say, sorry, we use scale. Once again, we use scale. So I had to join like this. Freehand curves will not use scale, but for frequency polygon, we have to use it. And you have to connect this line to the next point. What is the next point? In case if I have the class interval 10 to 12, you might be drawing over here, right? What's the frequency for 10 to 12? It's not given. So shall we assume it as 0? So this will be the midpoint. So shall I join over here? Likewise, if we had 0 to minus 2, that is minus 2 to 0. What's the class frequency? The negative side. No students. So 0. So I may extend my line over here and join for this. So your diagram will look like this. You call this as frequency polygon. What do you call this as? Frequency polygon. Again, go for the definition. What do you mean by polygon? Closed, bounded by straight line. Can you find a closed figure here? Can you find it here? See? See, it need not be perfect regular shape and all, like square or rectangle, need not be. See, I'm finding starts here and ends here. Goes here, goes here, goes here, goes here, then here, then here. It's bounded. Closed and frequency polygon. Instead of doing this way, if I join by freehand curve, which means I just roughly draw a figure, I just sketch it. You call this as frequency curve. You call this as frequency Hope it is okay. Done. Next, let me go for cumulative frequency graph. This is founded by Ojai. So you call this as Ojai curve. Some may be pronouncing this as Ogiv. Okay. Name only, anyway you can pronounce it. Ojiv, Ojai, Ochiv, Ogai. Okay, whatever it is, your wish only. Very easy. So, Ojai curve. I usually say Ojai curve, so I'm taking Ojai curve. Same like this, you have to proceed for drawing the curve. Can you help me out with the values? Yeah. Let me go for a y-axis. What units I can take? I cannot take 1, 2, 3 because it will go lengthier because I have the value 17 and all here. So shall I go in twos? Yeah, 2, 4, 6, 8, 10, 12, 14, 16, up to 17 I want. So 18. Yeah, your values. I have everything in 2, 4, 6, 8, 10. So let me have 2, 4, 6. No, I want to take 1, 2, 3 as usual. I'll explain you. I'll tell you why. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, please join with me, Pa. Tell me the coordinates for 0, 0. You can leave it off. 0, 0 means you'll start here only now. Yeah. 0, 0. 2 and 2. Yeah, please, please. 2 and 2. Yeah. 4 and 3. 6 and 10. Am I right? 6 and 10. 8 and 15 over here. Okay. Then 10 and 17. 10 and 10 is over here. 2, 4, 6 and 10. 8 and 17 over here. Then 10 and 15. 15, 10 and 17. Okay, let me join it as a freehand curve. Then for greater than CF, yes, let me take some other color. 0 and 17. Okay, yeah. 2 and 15. 2 and 15. Then 4 and 14. Yeah. 6 and 7. 6 and 7. 8 and 2 were 10 and 0. You'll find the shape of the curve as elongated X. What is X? It's been elongated, like elasticity effect. Like you'll find this as this type of a curve. It's called as an elongated X-shaped curve. I remember some few questions asked in the exam. You will find that this line, what is this curve? Drawn with the help of greater than CF values. This is called as greater than CF or J curve or greater than CF curve. Okay. What is this curve? The red line. Less than CF or J curve or less than CF curve. If you go for the features of less than CF curve, it will start with 0 and the slope of the curve will be traveling upwards. If you go for the greater than CF, it will start with the value 0 because obviously if we consider 0 and 17, we start with 0. So here, and it slopes downwards. And the point where it meets, if I draw a line, perpendicular line to the x-axis, we'll get the value called as median value. The intersection of the two Ojai curves is what you call as the median value. Don't worry about the term mean, median, mode and all because we'll be discussing all those in the next topic. Okay, so this is about less than CF and greater than CF. As I was discussing earlier, the original classification, you remember what I took? 0 to 1, 2 to 4. So it was unequal width. For that one, I did not use this table, frequency polygon and all because for frequency polygon, you cannot have unequal widths. If unequal width class intervals are given, you have to convert to frequency density. Then only you can find frequency polygon. So my graph will look somewhat haphazard-like. So for frequency polygon, you need to have frequency density if it is unequal. For histogram, not an issue because the bars will be somewhat of different shape. That's why. For histogram, not necessary to have equal or unequal widths. For frequency polygon, you should definitely have equal. If there is no possibility of having equal widths, because some data I am collecting it personally, it's a primary data, I can change it. But if I take another source, like secondary data, I cannot change the values, right? So in that case, for frequency polygon, I cannot draw the frequency polygon, but instead what I can do is I can convert to frequency density and I can find out. Okay. And one more thing, what's the difference between histogram and bar diagram? Can you please tell me? Seeing the diagram, what you understand? Histogram and bar diagram. The bars will be attached. In histogram, you can find the bars are continuous. But in the case of bar diagram, you will find gaps. It's very simple. The logic is very simple because this is quantitative classification. We are giving the values here. There we have like chronological or geographical classification. I'm not going to give the values. So this all the things asked in the exam. So you can make a note of it. Probably you can try drawing this one. Okay, you need not copy. You can try drawing this one. Probably I'll share this page to you. I shared it in the group. You can try drawing on your own. Just I'll make a tick mark. See what are the things we have discussed here. Frequency distribution done. Frequency distribution of a variable is how many class intervals you have and what is the class length. For the last class interval, we were taking 0 to 2, 2 to 4, 4 to 6, 6 to 8 and 8 to 10. What is the width of the class interval here? It's all 2. How many class intervals I have? 1, 2, 3, 4, 5. 5 class intervals into class length is what you call as the width or size of the class interval is 2, 10. What is the range? The last value minus the smallest value. 10 minus 0. Yes, you're getting. This is what you call as the frequency distribution of a variable. Okay. Then this we have already discussed. You call something called as mutually inclusive and mutually exclusive. Okay, you need not worry much on this. Class boundaries we have calculated with the formula. Adjustment factor also we have calculated. This is upper class boundary. You can please make a correction. With the help of this one also we'll find the mid values. The formula will somewhat look like similar one. Okay. When we talk about width or size of the class interval, please remember we have to use class boundaries only, not class limits. Okay, even for midpoints. Midpoints formula will be similar. Frequency density formula, class frequency divided by width of a class interval. Relative means always it's expressed in percentage only, class frequency divided by total frequency into percentage. Usually the range of the relative frequency will be 0 to 1. Please make a note. This was asked once in the exam. But when we talk in percentages, it will be 0 to 100. Okay. So relative frequency range will be generally 0 to 1. If we talk in percentages, it will be 0% to 100%. Graphical representation, histogram, another name for that is area diagram. Why we call this as area diagram means probably I'll take some. Okay, I just want to distinguish with the help of colors. See, I can talk about this complete area. See, when we talk about area, it means when we talk about a closed figure only, we can talk about area. For circle, we can talk about area. For any polygons, we can talk about area. Okay, so this, the shaded lines which I take, this all covers a two-dimensional figure, so I can talk about area. Okay. This and all you can just have a glance. Frequency, polygon, ogive curves, this and all I covered. Used for calculating medians and quartiles, you need not worry as of now. We'll discuss when we go for the next topic. We'll discuss in very detail. Okay. This is quite important. Frequency curve. When we draw a curve, usually we'll get any of this type of figures. Bell shaped. See, it will be like a bell. U-shaped, you will get a U-shaped curve. Then J-shaped, it will be like an umbrella stick where you can hold your hands over here. Then mixed curve, see, can you find from here to here, it is J-shaped. From here to here, if you check, it is bell-shaped. Here to here, you check, it is U-shaped. And here to here, actually it will increase. The slope will be going up and down. So this is mixed curve. You need not worry about this term because it is connected with the next topic. Cumulative frequency I have done. Probably here I was discussing with respect to 10 marks maximum. Here I have given with respect to 100 marks. You can just take this as an assignment. That's it. So this heading is over. So what's your assignment is, I'll share this picture in the group. So you can try drawing on your own. So first, classroom. For all the three problems, I'm going to give three problems. You'll draw histogram, frequency polygon, frequency curve, along with that, Ojai curves. You'll draw all the four. All the three can be done in one single graph and Ojai curve in another graph. Don't mix both. Okay. So classroom problem, which I'll be sharing the picture of this. Then second problem, SSA problem. Can you look at the problem? SSA problem, this problem, the last one. This one. For this, you'll find histogram, you draw histogram, frequency polygon, frequency curve, everything. And third problem, we'll go for the next topic. We can go for page number 2.17. This problem. 2.17. Can you find this heading? Marks, number of students. And you have to make a note that this problem has class limits. So you have to make it as class bounded, then you have to find it. So this is the third problem. Is it okay? So this is SSA problem. And third one, the same SSA problem from page number 2.17. What is this page number? Can you help me out with the page number? 2.1.17. This is 2.17. Okay. So finish these three problems and submit as an assignment.